rational zero theorem, right? So basically this rational zero theorem is if I have some polynomial, and remember this is the general form for any polynomial. You don't need to be you don't need to be concerned about what all those different letters and numbers mean. But just remember, it's some polynomial. It's any polynomial we can think of fits that form, right? And it has integer coefficients. Then we can find the rational zero of that function given this, p divided by q, where p is any factor of the constant and q is any factor of the leading coefficient. So before we get into all this nitty-gritty, what's the zero of a function? Yes?
The x-intercepts?
Yes. It absolutely is the x-intercept. Right? So we want to find out where the x-intercepts of a polynomial are, where the zeros of the function are. We want to have this. So this is kind of what we've been doing, right? So if I had 0 equals x squared minus 9x plus 20, and I said, solve this. Well, what am I solving for? What am I looking for?
X.
Right. But with the function, what does that x value represent?
What x has to equal for it to be equal to 0?
And what is that? Like it's the what?
Y-intercept. X-intercept.
It's the x-intercept. Usually we write our polynomials like this. We have an f of x or a y is equal to this. Well, what changed from the top one to the bottom one? Y became 0. Well, if I have my coordinate grid, y and x, where's y 0? Where's y 0? All along the x-axis. So every point on this x-axis, y is going to be 0. So if I suddenly made y 0, basically I'm saying, hey, where is this function going to hit the x-axis? Well, here we get x minus 5, x minus 4. So we know x is going to be equal to 4 and x is going to be equal to 5. So I have a parabola that looks just like this, right? 4, 5. Crosses the x-axis there. That's all we're saying. And that's all we've done so far. So questions on the terminology and the background for this? Now some of you are probably thinking, well, okay, great. So why do we need to know this rational zero theorem if we can just look at all this stuff?
For the leading coefficient, is it a to the what? I can't see.
A to the n.
Here, a sub n.
Oh, okay.
Okay, you don't need to worry about that. It's just a leading coefficient. So
Wait, what's an integer again?
any positive, negative whole number.
Okay.
It's all right. So here, there's my function, right? So I can find where this crosses the x-axis. How have we been solving functions and polynomials so far?
Factoring.
We've been factoring. Great. So all we have to do is set this equal to 0 and factor, correct? Can we factor this?
Don't remember it.
No, we cannot.
We can by grouping.
Okay, go for it.
No, you actually can't.
No, you can't.
No, because 2 and
Thank you.
12 and then x squared and negative 1x.
Sure.
Is it wrong? Right?
So here's the hint. Given that this is in this section, we can't factor this. You're right. If we see 4 terms like this, chances are our best bet to factor is to factor by grouping. Unfortunately, here we can't do that. So we can't factor this. So in order to find out where they're going to be rational zeros, we have to use the rational zero theorem. So we have to look at my p's and my q's. So my p's are going to be all the factors of
12.
Constant.
the constant of 12. So what are all the factors of 12? 1, 2, 3, 4, 6, and good, because 2 times 6 is 12. What about negative 2 times negative 6? Still 12. So we
So
We
plus
can't.
or minus.
Plus or minus.
all the-
Yep, so all these are going to be plus or minus. And my q's. Q's are going to be all the factors of,
1.
what's 1?
X to the third.
The leading coefficient. It's the integer value in front of x to the third. So this is going to be
Minus 1.
plus or minus 1.
They have 1 in common.
Well, we don't really care about that.
Oh yeah.
Nope, because remember, we're dividing. It's nice that the q only has one factor, because now we only have to divide each number by just this one. If there were, say, 5 q values here, we would have to divide each one. We have to find every combination of p over q there is. So here we just have to divide p divided by q. So this is going to be plus or minus 1 over plus or minus 1. Plus or minus 2 over plus or minus 1. Plus or minus 3 over plus or minus 1. So I'm just, it's extremely annoying, but I'm writing all this out just so we don't miss anything. But really, I'm dividing all of these by plus or minus 1, so what are these really?
The plus or minus the number.
Yeah, exactly. They're still the same thing, right? They're just my p-values. So those are my possible zeros. So when I say possible zeros, what do those numbers show me?
If those are plugged in for x, the y function will equal 0.
Yeah. More specifically, more lamest terms, what we call that?
Those are the x-intercepts.
All of them?
No.
Right. They are the potential x-intercepts.
That was cherry on top right there. That was good.
So here, like if I give you this function, I say find the x-intercepts. There's probably an infinite amount of numbers, right? You have to try and plug in each infinite value into there. Well, what we did, we condensed that infinite string of possibilities into 12. It's pretty nice. I know some of you are like, oh man, we have to try all these 12 numbers. Okay, if you want to go back and start plugging in from negative a million, go for it. Oh, you sure?
Yeah.
Okay.
I was gonna ask. Hey, isn't it just 6 because they're negative or positive and it's just changed the sign?
Could be positive 1, could be negative 1. Positive 2, negative 2. Positive 3, negative 3.
No, I'm saying, but like
Since you're
when you plug in 3, can't you once you get your answer for 3, can't you just change the sign?
It's not symmetrical,
Okay.
right?
If it was a plus 2x squared plus 11x, you could do it, right? No, you couldn't. I get
Right?
that.
Because even if it were a parabola, there's no way. Well, I mean, even if it were a parabola, remember, axis of symmetry is going to be x equals negative b over 2a. So unless that is equal to 0, we can't definitively say. But knowing that, hey, that's something helpful that if you do get a quadratic. But quadratics are typically easier to factor than this.
I think you already said this, but I'm just making sure. Are those all the possible x-intercepts?
Yes.
Okay.
Right? These are the possible rational zeros. and the possible x-intercepts. All right. So here's how we actually find this, right? Now we can say find the real zeros of this function. So this is where we would factor. And can we factor this? Yeah, hint no. No. Always look to try and factor it. But chances are, since this is a problem in this section where we can't factor them, you can't factor them. So we have to look at the possible ones first. So P. P are my factors of
Plus or minus 1.
-4.
-4. P are the factors of the constant. So factors of 4 are
Plus or minus 1.
plus or minus 1
Plus or minus 2.
and
Minus 4.
and then we have my Q values, which are the factors of
Plus
Two.
or minus 1. Plus or minus 1.
So in order to find the possibilities, I do P divided by Q, which is going to be
Plus or minus 1 over plus or minus 1.
plus or minus 1 over plus or minus 1,
Plus or minus 2 over plus or minus 1.
plus or minus 2 over plus or minus 1,
Plus or minus 4 over plus or minus 1.
plus or minus 4 over plus or minus 1, plus or minus
1 over 2.
plus or minus 1 over plus or minus 1, plus or minus, whoops, plus or minus 2 over plus or minus 1,
Why would you do plus or minus 1 over plus or minus 1?
and plus or minus 4 over plus or minus 1. Again, this is the first time we're looking at this. I just, hold on. This is the first time we're looking at this. Oh, sorry. It's the end of the day. It's the end of the day. Is that an excuse?
That's what I was thinking.
Let us all.
Quiet down.
What happens on the repeats?
So look. Given that this is the first time we're looking at this is why I'm writing this all out. Do you necessarily have to write out this step? No. I mean, we're dividing by 1 and 2. I'm assuming most of you can do that stuff in your head. If you need to write it out, like I know sometimes writing this stuff all out really helps and helps us avoid mistakes. Absolutely go for it. But if you're sitting here like, I don't need this, then don't do it. I'm writing this out to show you guys all these possibilities, and now I can reduce. So the possibilities are, and I guess I'll write this here.
Plus or minus 1.
Plus or minus 1, and then 2 divided by 1 is?
Plus or minus 1.
2 divided by 1.
2.
4 divided by 1 is? Well, 1 divided by 2 is? Plus or minus 1/2. Then I have 2 divided by 2, which is? I already have that.
Yeah, you don't have to write it again.
I don't have to write it again. 4 divided by 2 is? 2. So these are the possibilities. So I took an infinite amount of possible x-intercepts, and now how many do I have?
4.
8.
8.
Oh.
So if these are possible ones, how can I figure this out?
Plug them back in. See if it equals 0.
Oh. Tisk, tisk, tisk. What did we just learn how to do?
Synthetic diversion.
Synthetic division.
We have that.
So think about it this way. If I have a 0, which is if I have a 0 which is 1, what is the factor that gave me that 0? Well, remember when we're solving for x-intercepts, when we're solving for zeros, what do we set a factor equal to? We set the factor equal to 0. So what should I want this to be equal to?
Negative
0.
0. I want this to be some factor equal to 0. So what I do is I subtract 1 from both sides, and now I have x minus 1 is equal to
0.
So what was the factor that gave me the x-intercept, or the 0, of 1?
Negative.
Positive 1.
Negative.
What was the factor?
Sorry.
Plus or minus 1.
Plus or minus 1.
But no, guys, what was the factor?
X.
x minus 1. Right? Remember, if I had x squared minus 9x plus 20 equals 0, remember we factored this? This is so last chapter, right? We use the zero product property. And then we get x is equal to 5 and x is equal to 4. Now what we're doing is we're working backwards. So now we're saying, hey, we have an x-intercept that is x is equal to 5. Well, what was the factor that gave me that 0? Well, it must have been x minus 5.
So x minus 1.
So here the factor would be x minus 1.
And then that's
For
it.
synthetic division, it would end up being positive.
Good. So I'm just explaining this so that we can find out. So I'm just using this so that we can find out what the factor is, right? But here, yeah, what we're actually going to do is we can use synthetic division. You can use polynomial long division for this, but it's a little bit longer. Synthetic division is really quick. Because with synthetic division, we're trying to figure out if this goes in evenly or not. And how could I find out if it's even or not? If we have a remainder or not. So we're going to start off with positive 1. So I can put out my positive 1 on the outside, and what goes on the inside? 2, negative 1, negative 7, 4. Now we synthetically divide. So bring down the 2. 2, 1, 1, negative 6, negative 6, negative 2, negative 2. What's this? Remainder. What's a remainder mean?
Does not equal.
Does not go in evenly. So that must mean
It's not the answer.
positive 1 is not a 0.
Does that mean you just need -1?
So now we go back. Now we try negative 1.
Such a
Again, yeah, but we're trying 8 numbers from infinity. And once we get 1, we're a little bit better off. So negative 1, and on the inside still goes the same thing. 2, negative 1, negative 7, 4, negative 4. So bring down the 2. Negative 2. Negative 3. Negative 4. 4. 8. Negative 8. Negative 12. What's that? Remainder. So it gives me a remainder. So it's negative 1 a 0. So that means that neither positive 1 or negative 1 are x-intercepts. So now I can try, let's say, positive 2. And then I go to 2, negative 1, negative 7, 4, negative 4. Bring down the 2. What do I get? 2.
4, negative 3.
Sorry, positive 3, yep. 6, negative 1,
Negative 2, 4, 0. Yo.
whoa. Remainder?
No.
No. So now, what are my 2 factors?
2
X plus 1.
X,
Plus 2.
x minus 2. Remember, we take the opposite of what's out there. And then 2x cubed plus
3x squared
3x squared
minus x
plus x
plus 2.
plus 2.
That is the answer.
So it says find all of the possible zeros, correct?
Yeah.
So we get 1. 1 was what?
Negative
1 was positive 2. Can I factor this?
No.
No. So what should I probably do here?
And then
What's that? What?
Well, you're only trying to find the
oh, you plug.
real zeros,
You
so
plug
you
it
don't
in?
need to factor it.
I don't?
Isn't that not the point of the problem?
Yeah.
What do I want to find?
You just want to find the
Well, would you do the
zeros,
same
like
thing?
what?
Do the
works.
exact same thing,
P over. Oh, that makes sense.
right?
Find
Um,
your P's and find your Q's.
If I could factor this, that would be great. That would be absolutely great. I could factor it, I'm done.
But
I can't factor that. So what I do is I do the same thing over again. I find my P's or my Q's. So my P's are going to be plus or minus 1, plus or minus 2. My Q's are going to be plus or minus 1 over plus or minus 2. And I'm going to have, this could either be plus or minus 1, plus or minus 2, plus or minus 1/2. Now the nice thing about this is, do I start with plus or minus 1?
No.
Why not?
Because you did it.
I already did 1 and negative 1. They're not going to work.
We already did 2.
We already did positive 2. We know that works. So,
Do a half.
what's that?
Throw
What?
a half in there.
So we could start all over again from positive 2.
oh, so all we're doing is like it's like lowering the possibilities down and down, right?
Mm-hmm. Again, if we had like the example I used before, x squared minus 9x plus 20, we could factor that. So if you could factor that,
You're done.
you're done. That's great because you could find x is 5, x is 4. Here we have to keep going. So let's start again with 2. So we get 2, 3, negative 1, 2. Bring down the 2. We get 4, 7, 14, 13. Yeah, that's... I can already tell, right? I don't even need to do the math. This is going to be 28. No remainder. So is 2 a factor of that? Or is 2 a possible 0? Sorry. Is 2 a real 0? No. So now I go back. 2, 3, negative 1, 2. What do I put on the outside? Go with negative 2. Bring down the 2. It's going to be a negative 4, negative 1. It's going to be a positive 2. It's going to be a negative 1. This is going to be a positive 2. Ooh. So close. Oh, wait. Ah! I did the math wrong.
Yeah.
Oh yeah.
So, is negative 2 a 0?
Yeah.
So, what is this now? 2x squared minus x plus 1?
Yeah.
Ooh, can I factor that?
Yeah.
Negative 2 and
Minus 1.
Look at that. So now, this whole thing worked out is going to be x minus 2 times x. What was the factor that gave me a 0 of negative 2?
X plus 2.
X plus 2 times 2x plus 1.
2 and x minus 1.
X minus 1. Oh, wait. So negative 1 should have worked then.
What? Wait, then what happened to the first positive 2? Because that didn't work on the second one. Does that mean that it's just... What did that work on the second one?
2x squared minus 2x.
Yeah, tonight's homework is gonna be so fun.
Oh, you know what? No, sorry.
We don't have class
No, sorry. You can't factor that last one. So that's going to be 2x squared
tomorrow. Minus 1.
minus x plus 1.
Oh, because
Right? So my possible 0, or my actual zeros are x is going to be equal to positive 2 and negative 2.
Wait, so why can't you factor there?
Because we need this middle term to be a negative 1 and the outside term to be a positive 1. So they need to be the same, and we're either going to get 3x or negative 3x.
But then don't you need to test 1/2?
Well, so the beauty thing is, we don't need to test the 1/2 and the negative 1/2, because once we get down to something that we actually can factor,
then it means
we can factor it. And here, we can't factor this. But it's something that we could factor. It's a quadratic. We know quadratics always factor into
Oh, so
two binomials.
two or like a trinomial that's a quadratic. Oh, it's factored into 2 binomials. So we try and factor it into there. And can we?
No.
No. So we're done. No rational zeros there. No real
So
zeros.
what's the final answer? Plus minus 2.
So we plus minus 2.
Wait, is that factoring that, or is that?
From the x minus 2, we get positive 2. From the x plus 2, we get negative 2. This right here is not going to give me a rational real 0. Okay?
Oh, since you couldn't factor it, it's not part of the answer.
Correct.
Oh.
Are you done?
Do you want to be done?
Please.
No, we got some more work to do. I'm going to stop the recording though.